In this video, we are going to be going over cross-section of the spinal cord. So what you see what I have on the board in front of me here is a cross-section of the spinal cord, which is a transected cut right through the spinal cord. So you're looking at it kind of like a bird eye view here. So just to orientate you here, here's the back, the dorsal. Here's the front, the ventral. So again, bird eye view, this is the front, this is the back here. So this could be any part of the spinal cord. And what I have coming in on one side is a spinal nerve. Okay, so a spinal nerve. Now understand that spinal nerves come in at different sides, but I'm only going to show on one side just to simplify this drawing for you. So, a few aspects I want to describe on this diagram for you before I start throwing in the motor and the sensory aspects of it. You see a small circle right in the middle. This small circle right in the middle here is the central canal. The central canal is what holds the cerebral spinal fluid. Cerebrospinal fluid, the same type of fluid that flows inside the brain and around the brain. So the cerebrospinal fluid. Now if you remember in the brain structures, it goes down the aqueduct, cerebral aqueduct, fourth ventricle, all the way down into the central canal of the spinal cord. And so that's where cerebrospinal fluid is. Around the central canal is gray matter. Now if you remember, you know gray matter is unmyelinated. Okay, it's unmyelinated. So with unmyelination, with no myelin, signal slows down. Now why is signal slowing down? This is where information gets processed in the spinal cord. The brain doesn't do all the processing. The spinal cord will try to process some of the information that's coming to it. And whatever it doesn't process, it sends it right up to the brain. So the gray matter is where the processing curve signal is a little bit slowing down. The white matter out here is myelinated. Now the white matter with the myelination speeds up signals, speeds them up, so they go in very fast. This is where it's going to send information to the brain. This is where information is going to be coming down from the brain. This is where it's going to be sending things out to the spinal nerves and coming right back out. So white matter very fast. Gray matter slowing down. That's an area where information is being processed. Myelination, non-myelinated, unmyelinated. Alright, so looking at spinal nerve coming in. The spinal nerve splits off into two different parts. You have, these are called roots. You have a dorsal root and a ventral root. So I'm going to put that down on here. Dorsal root and ventral root. Okay, so it splits off right there. That's where information is going to split off into different parts of the spinal cord. Now, notice how information goes to the spinal cord. I'm going to use two different colors. I'm going to use blue for sensory input, and I'm going to use red for motor output. So I'm going to put that down as kind of like a little bit of a key up here. So blue is sensory, red is motor. Alright, so how can you tell the difference between the dorsal root and the ventral root? Dorsal root is going to have this little swell up region. This is called a ganglion. So I'm going to put that down in here. Ganglion. A ganglion is where cell bodies gather. So you have a whole bunch of cell bodies coming in. Now remember, a neuron, a cell body, is the main part of the neuron. So you have the dendrites, the cell body, and the axon. So in a dorsal root, this is where cell bodies gather. Okay, it does not gather at the ventral root, so that's why the ventral root does not have a ganglion. Alright, so how does the information go to the spinal cord and how does it leave the spinal cord? Information going to the spinal cord or going to the central nervous system is the definition of sensory. Sensory going to the brain and spinal cord. So I'm going to start off with blue for sensory information. Sensory information coming into the spinal cord like here, and where the spinal nerve is splitting off is going to go down the dorsal root. So it goes down the dorsal root like that, and it's going to end up coming in right here in the spinal cord. This region of the spinal cord right here is a region that deals with sensory information. It receives sensory information right there. And this is where it actually can send sensory information up towards the brain for the brain to process it, and it actually can extend out into the gray matter here, where it can actually try to process some of the sensory information itself. And so it has those two options: to the brain, or it's going to try to process it itself. And so when it's processing itself, let's say it's going to go through that gray matter. It's going to go through some integration, some deciding what is the proper response necessary, and it's going to send out into a motor signal out towards the effector organs. So once it's made up its decision, I'm going to use red to represent motor signals, and it's going to go down the ventral route here. Now, the motor signals, they are made at the ventral part of the spinal cord, and that is sent out towards the effector organs, or if it's coming from the brain, it's coming down, hitting in this area here. It's going to be down from brain. It's going to go to the ventral area of the spinal cord before it's sent out. So some things you want to keep in mind with this. First of all, ventral. Ventral part of the spinal cord deals with motor function. You want to always remember that. Ventral means motor. Dorsal deals with sensory. Always deals with sensory. So that side and this side all deals with sensory. Ventral side deals with motor function. Now this is very important when it comes to spinal cord injuries. If someone's spinal cord was injured only on the front side, they will still have the ability to sense things, but they cannot function anymore. They cannot have any motor function. So if I had a spinal cord injury that affected my hands, okay, if it was a front part of the spinal cord, I can still feel, but I can't move my fingers. Okay, vice versa. If I damage my spinal cord on the dorsal side, I can't feel, but I can still move because I still have the motor function intact. But if it was a complete transection throughout the whole spinal cord, I have paralysis, complete paralysis, no sensory, no motor from that point below. So if it was transected between my arms and my legs, okay, like right here in the thoracic region, I'll be known as a paraplegic. Okay, paraplegic. I still have function in my arms, but I lost function from that point down. Now, if I had a spinal cord injury in the cervical region and the neck above my arms, I lose motor and sensory from this point down. So I would be considered a quadriplegic. So completely no motor function, sensory function from that point down. Okay, so that is a good review over the spinal cord, how it receives information. Remember, it receives sensory on the dorsal side. Then the spinal cord has to make a decision. Can I process this myself, or do I need to send it up to the brain? And then it comes back down from the brain, and then it sends it out through the motor pathways that starts off in the anterior, the ventral part of the spinal cord. Okay, and so if you have any questions, please post them on the forums, and good luck studying for the spinal cord, and stay tuned for more videos on the nervous system.